Hello everyone, and here we are with our third mathematician of the year, and her name is Marrjorie Rice. The reason why I like to talk about her is the fact that she's not actually a mathematician. She's what's called an amateur mathematician. She did not go to school to study these things. So Marrjorie Rice, she was born in 1923, and then she lived all the way to 2017. She was born in Florida and then eventually moved to California with her husband, and that's where she lived the rest of her life. So she really only took 1 year of math in high school. In her younger years, she went to a one-room country school where she skipped 2 grades and studied with the older kids. Though she loved learning, and particularly her brief exposure to math, poverty and cultural norms prevented her family from even considering that she might attend college. And I think that in and of itself is a little bit different than what you guys are experiencing now, right? I mean, the assumption is mostly that you go to college, and that wasn't the case back then. So in December 1975, she came across a Scientific American article, and really she actually had a subscription to Scientific America. She got it for one of her sons, but she would sneak and read it while they were all at school, which I think is kind of cool. Her kids said that she would read avidly, and she used her mind actively, deeply, and regularly. And in general, she was fascinated with the golden ratio and the pyramids, which I think is cool. I love the golden ratio too. We're going to talk about that later in the year. Anyway, so she was just a curious person, but had not studied a whole lot of math. So she read this article about tessellations. So tessellations is basically a tiling pattern. So that you basically, tiles, right? So the shapes connect together with no holes and no overlapping, and the pattern can continue on forever. That's the tessellation. We're going to talk about those in third quarter. Okay? She devoted her free time to discovering new pentagonal tiling. So pentagonal meaning pentagons. So 5-sided shapes. And she actually discovered, I think, 4 different types that mathematicians up until that point had thought they had figured out all of them already. She developed her own system of notation to represent the constraints on and relationships between the sides and the angles of the polygons, and used it to discover 4 new pentagons and over 60 distinct tessellations by 1977. So 2 years she discovered like 64 different tessellations, which I think is just awesome. And it was just something she wanted to do. This wasn't her job or any of those things. Her work was eventually examined by a math professor named Doris Schacht-Snyder, who deciphered the unusual notation and formally announced her discoveries to the mathematics world. Rice declined to lecture on her discoveries, citing shyness, but at Schacht-Snyder's invitation, she and her husband attended a university mathematics meeting where she was introduced to the audience. Rice still said nothing of her achievements to her children, but they eventually found out as the accolades mounted. She was interviewed for The Nature of Things, which was a documentary in 1996, and a tile floor in the lobby of Mathematical Association of America in Washington exhibits one of her pentagonal tessellations. She commemorated her pentagon patterns in Escher-esque paintings. Anyway, she said she did it just for the sake of discovery, according to her daughter. Nonetheless, she was happy to get recognized. Here she could find something that other mathematicians had searched for. Schacht-Snyder, again, that mathematician that she worked with, has lauded Rice's work as an exciting discovery by an amateur mathematician. So, who knew, you could make contributions to the mathematical world and not have a mathematics degree. And I think that's really awesome. And when we talk about tessellations, I hope we have fun. Thanks, guys.